The Decline of the West by Oswald Spengler. Volume 1, Form and Actuality. Chapter 2, Meaning of Numbers, Part 6. The Greek mathematic, as a science of perceivable magnitudes, deliberately confines itself to facts of the comprehensibly present, and limits its researches and their validity to the near and the small. As compared with this impeccable consistency, the position of the Western mathematic is seen to be, practically, somewhat illogical, though it is only since the discovery of non-Euclidean geometry that the fact has really been recognized. Numbers are images of the perfectly desensualized understanding, of pure thought, and contain their abstract validity within themselves. Their exact application to the actuality of conscious experience is therefore a problem in itself, a problem which is always being posed anew and never solved. And the congruence of mathematical system with empirical observation is at present anything but self-evident. Although the lay idea, as found in Schopenhauer, is that mathematics rest upon the direct evidences of the senses, Euclidean geometry, superficially identical though it is with the popular geometry of all ages, is only in agreement with the phenomenal world approximately and within very narrow limits. In fact, the limits of a drawing board. Extend these limits, and what becomes, for instance, of Euclidean parallels? They meet at the line of the horizon, a simple fact upon which all our art perspective is grounded. Now, it is unpardonable that Kant, a Western thinker, should have evaded the mathematic of distance and appealed to a set of figure examples that their mere pettiness excludes from treatment by the specifically Western infinitesimal methods. But Euclid, as a thinker of the classical age, was entirely consistent with its spirit when he refrained from proving the phenomenal truth of his axioms by referring to, say, the triangle formed by an observer and two infinitely distant fixed stars. For these can neither be drawn nor intuitively apprehended, and his feeling was precisely the feeling which shrank from the irrationals, which did not dare to give nothingness a value as zero, i.e. a number, and even in the contemplation of cosmic relations shut its eyes to the infinite and held to its symbol of proportion. Aristarchus of Samos, who in 288 through 277 belonged to a circle of astronomers at Alexandria that doubtless had relations with the Chaldeo-Persian schools, projected the elements of a heliocentric world system. Rediscovered by Copernicus, it was to shake the metaphysical passions of the West to their foundations, witness Giordano Bruno, to become the fulfillment of mighty premonitions, and to justify that Faustian, Gothic world feeling which had already professed its faith in infinity through the forms of its cathedrals. But the world of Aristarchus received his work with entire indifference, and in a brief space of time it was forgotten, designedly, we may surmise. His few followers were nearly all natives of Asia Minor, his most prominent supporter, Seleucus, about 150, being from the Persian Seleucia on Tigris. In fact, the Aristarchian system had no spiritual appeal to the classical culture, and might indeed have become dangerous to it. And yet it was differentiated from the Copernican, a point always missed, by something which made it perfectly conformable to the classical world feeling, viz. The assumption that the cosmos is contained in a materially finite and optically appreciable hollow sphere, in the middle of which the planetary system, arranged as such on Copernican lines, moved. In the classical astronomy, the Earth and the heavenly bodies are consistently regarded as entities of two different kinds, however variously their movements in detail might be interpreted. Equally, the opposite idea that the Earth is only a star among stars is not inconsistent in itself with either the Ptolemaic or the Copernican systems, and in fact was pioneered by Nicolaus Cusanus and Leonardo da Vinci. But by this device of a celestial sphere, the principle of infinity, which would have endangered the sensuous classical notion of bounds, was smothered. One would have supposed that the infinity conception was inevitably implied by the system of Aristarchus. Long before his time, the Babylonian thinkers had reached it. But no such thought emerges. On the contrary, in the famous treatise on the grains of sand, Archimedes proves that the filling of this stereometric body, for that is what Aristarchus's cosmos is, after all, with atoms of sand leads to very high, but not to infinite figure results. This proposition, quoted though it may be time and again as being a first step towards the integral calculus, amounts to a denial, implicit indeed in the very title, of everything that we mean by the word analysis, whereas in our physics the constantly surging hypotheses of a material, i.e. directly cognizable aether, break themselves one after the other against our refusal to acknowledge material limitations of any kind. Eudoxus, Apollonius, and Archimedes, certainly the keenest and boldest of the classical mathematicians, completely worked out, in the main with rule and compass, a purely optical analysis of things become on the basis of sculptural classical bounds. They used deeply thought out, and for us hardly understandable, methods of integration, but these possess only a superficial resemblance even to Leibniz's definite integral method. They employed geometrical loci and coordinates, but these are always specified lengths and units of measurement and never, as in Fermat and above all in Descartes, unspecified spatial relations, values of points in terms of their positions in space. With these methods also should be classed the exhaustion method of Archimedes, given by him in his recently discovered letter to Eratosthenes on such subjects as the quadrature of the parabola section by means of the inscribed rectangles, instead of through similar polygons. But the very subtlety and extreme complication of his methods, which are grounded in certain of Plato's geometrical ideas, make us realize, in spite of superficial analogies, what an enormous difference separates him from Pascal. Apart altogether from the idea of Raymond's integral, what sharper contrast could there be to these ideas than the so-called quadratures of today? The name itself is now no more than an unfortunate survival. The surface is indicated by a bounding function, and the drawing, as such, has vanished. Nowhere else did these two mathematical minds approach each other more closely than in this instance, and nowhere is it more evident that the gulf between the two souls thus expressing themselves is impassable. In the cubic style of their early architecture, the Egyptians, so to say, concealed pure numbers, fearful of stumbling upon their secret, and for the Hellenes, too, they were the key to the meaning of the become, the stiffened, the mortal. The stone statue and the scientific system deny life. Mathematical number, the formal principle of an extension world of which the phenomenal existence is only the derivative and servant of waking human consciousness, bears the hallmark of causal necessity and so is linked with death as chronological number is with becoming, with life, with the necessity of destiny. This connection of strict mathematical form with the end of organic being, with the phenomenon of its organic remainder, the corpse, we shall see more and more clearly to be the origin of all great art. We have already noticed the development of early ornament on funerary equipment and receptacles. Numbers are symbols of the mortal. Stiff forms are the negation of life. Formulae and laws spread rigidity over the face of nature. Numbers make dead. And the mothers of Faust II sit enthroned, majestic and withdrawn in the realms of image unconfined, formation, transformation, eternal play of the eternal mind, with semblances of all things in creation, forever and forever sweeping round. Goethe draws very near to Plato in this divination of one of the final secrets. For his unapproachable mothers are Plato's ideas, the possibilities of spirituality, the unborn forms to be realized as active and purposed culture, as art, thought, polity, and religion, in a world ordered and determined by that spirituality. And so the number thought and the world idea of a culture are related, and by this relation, the former is elevated above mere knowledge and experience, and becomes a view of the universe, there being consequently as many mathematics, as many number worlds as there are higher cultures. Only so can we understand as something necessary the fact that the greatest mathematical thinkers, the creative artists of the realm of numbers, have been brought to the decisive mathematical discoveries of their several cultures by a deep religious intuition. Classical Apollonian number we must regard as the creation of Pythagoras, who founded a religion. It was an instinct that guided Nicolaus Cusanus, the great bishop of Brixen, about 1450, from the idea of the unendingness of God and nature to the elements of the infinitesimal calculus. Leibniz himself, who 2 centuries later definitely settled the methods and notation of the calculus, was led by purely metaphysical speculations about the divine principle and its relation to infinite extent to conceive and develop the notion of an analysis situs, probably the most inspired of all interpretations of pure and emancipated space. the possibilities of which were to be developed later by Grassmann in his Ausdehnungslehr, and above all by Riemann, their real creator, in his symbolism of two-sided planes representative of the nature of equations. And Kepler and Newton, strictly religious natures both, were and remained convinced, like Plato, that it was precisely through the medium of number that they had been able to apprehend intuitively the essence of the divine world order.